So for A, the first thing we look at is we see that the magnitudes are all the same, so that's a plus, so that has to be true. Then we look at the phases and see if they're 120 apart. So so just take negative 105 and subtract 15 and see if you get plus or minus 120. And negative 105 minus 15 is negative 120. But then negative 135 minus 105 is not 120. Except that's a sign. Whoops, I didn't notice, that's a sign. So, so how do you change a sine to a cosine? You subtract 90. Subtract 90. So the C would be VC equals 169.7 cosine 377t. They do have to have the same frequency. They do all have the same frequency. And if I subtract 90 from that, I get 225. Degrees. And then if we check negative 225 minus 105, that is negative 120, so it does go. So if I go at 15 minus 120 is minus 105, negative 135 minus 120 is minus 225. So it is balanced, so definitely balanced. Now, is it a positive or negative phase sequence?
Negative?
It's actually positive, so it's like, because positive is when you subtract 120 degrees.
And then you add.
Yes, you go negative 120 this way and positive 120 this way. So a positive phase sequence looks like you go, you have your initial voltage, so that would be VA or V1, depending on whether you were Y or delta. And then you subtract 120, so that one would be VB, and then you add 120, and that one would be VC, and that's a positive phase sequence. But it doesn't look positive to me. To me, I would name them the other way around, but they didn't ask me. All right. So part B. So first, they're all cosine. They all have 311 as the magnitude. They all have omega as the frequency, so that's good. And are they separated by 120 degrees?
I think so.
Yeah. If you add 120 to negative 12, you get 108. And if you add 120 to 108, you get 228. So yes, so B is balanced, and is the phase sequence positive or negative?
Positive.
That one's negative.
And this is negative.
Yeah.
Because we're adding.
Because you're adding. But remember, it can be tricky because let's say I had the following numbers. Let's say I had, I'll make it 10 degrees. And then let's say I had 260 degrees. Wait, no, I have 10 degrees, and then I have can't think. Hold on. $250 degrees. And then I have 130 degrees. Is that positive or negative? Well, first, is it balanced? And then is it positive or negative phase sequence? And this actually, yeah, that's what I want.
I don't think it's balanced.
Well, what's 10 minus 120?
What's that, negative 110?
And now add 360 to that.
250.
So 250 is the same as negative 110.
Oh, okay. That's interesting.
And then what if I subtracted 120 from 110?
230?
Negative 230. Now add 360 to that.
Should be 130. So it's balanced.
Yeah, and then is it positive or negative?
Positive.
Positive.
Yeah.
All right. So we have I have a problem. Did I not put the solution for this? Okay, so we have a balanced delta source with a positive phase sequence, and we want to get from that V2, 3, V3, 1, and then V1, V2, and V3 of the equivalent Y. Okay, so V2, 3, what's going to be the same and what's going to be different?
The magnitude is going to be the same, but the angle's going to change.
Right. So 240 cosine, and the frequency will be the same, so
Right.
it'll still be 120 pi t, and then do I add or subtract 120 degrees?
Well, for V23, we subtract, right?
Right. So it'd be 140
Mm-hmm.
degrees. Whoops. Volts. And then V3 1,
We add it.
we'd add it.
Mm-hmm.
So we'd have 240 cosine 120 pi plus 100 degrees.
Mm-hmm.
Okay. All right. Now, how do we change it to
Y.
Y?
We divide by the square root of 3, we subtract 30 degrees.
That's right.
Okay.
So we'd have 240 over the square root of 3, whatever that happens to be.
I got 138.6 for the magnitude,
All right.
and the angle's negative 50.
What'd you say that number was?
138.6.
138.6.
And negative 50 for the angle.
for which one?
Oh, just for V1. The angle is -50.
Negative 50. Okay, and then what would V2 and V3 be?
So V2 would be -170. and
Mm-hmm.
we
That
went
was
to track
V1.
For V2, I was talking about.
So V2 would be negative 170.
Right.
Yep.
And then V2 would be 70.
V3 would be plus 70. Okay, so those are easy. All right, moving along. Okay. So here I have a balanced delta source with a positive phase sequence. And we want to get, so same problem. Wait, that's what we just did? No, it's a different problem.
That's different, yeah.
But it's the same idea,
Yeah.
right? Yeah, we can skip that one.
Okay.
All right, let's go on to 10.8. I thought I did one that was delta to y and one that was y to delta, but they were both delta to y, right? Yeah. I do need my electricity, my charger.
Oh, gotcha.
I think it'll reach over to that one.
You got power?
I got power. Yes, I do. All right. So is this delta or y?
Let's see here. I want to say why.
Yes. I want to say y? I do want to say y.
Is it because the impedances maybe? Because it's just the A, ZA equals one. What if it was like ZAB, ZA? Would that signify delta?
No, because the impedances are always just going to have the one letter.
Okay.
Let's
It's
take
not
a.
bad. You're right.
So let's take a look at the, our pictures here. And what we want to look at is, are the voltages, are we going to be measuring them relative to each other, which means we're looking at delta, or are we measuring them relative to a neutral or to ground, which would make it y? So when we look at y, our line currents are the same as our phase currents, and we're measuring the voltage relative to neutral. And when we're looking at delta, we have our line currents are not the same as the phase currents, because the line currents, well, because they're not. So let's take a look at ours and see what kind of configuration it has. think my solution here doesn't go with this problem. This solution does not go with this problem. That's not this problem. Okay, that's much better. I was like, but wait, that doesn't match. I'm looking at the wrong things altogether. No wonder they don't match. I'm looking at the wrong handout. So this one is Y, because I was saying it had to be Y, and I was like I couldn't see why my solutions were saying it wasn't Y. So if you look, both our voltages are measured relative to ground, and our line currents are the same as our phase current. So we have a Y source and we have a Y load. So how would we determine the line current right here?
It'd be V over ZA.
Mm-hmm. So that would be IL1, and yeah. So it'll be V1 over L1.
Okay. Yeah.
I mean V1 over ZA.
I got 7.84 equaling 13.7.
Mm-hmm. Angle, what?
13.7.
13.7 amps. Okay, and then you don't actually have to do that for the others, because now we know if it's a balanced, is it in positive or negative sequence? You don't even have to know that. You can just look at the angles and see, okay, I'm going down by 120. And so these will also go down by 120. So you subtract 120 and negative 106.5, and then you would add 120. So you don't have to do each one if it's balanced, which is one of the things that makes balance nice. Okay, so now we're going to do a harder one. So I'm going to give you a circuit. Okay, so those are my voltage sources. It's balanced. The top one is 120 angle 0, and it's in positive phase sequence. So that's all I'm going to tell you about it, is that it's balanced in positive phase sequence. And that's our source. Okay, and then is going to be set up like this. And our transmission line has some resistance. Our transition line, they're identical and they each have 3 ohms. That's a big ohm. So that's our transmission line impedance. And it's the same for all 3. And our load impedances are 25 plus J5. So Z, A, B, and C. All the same, 25 plus J5. Okay, so what are we going to do? Why is this one a little harder than the one we did just a minute ago?
Because we're not given the voltage components of the other 2.
Oh, yeah, we do. We are.
Oh.
We have. I said I wasn't going to give them to you because I was going to make you figure them out yourself. I said it was positive phase sequence and balanced.
Okay.
So you know what they are.
Alright.
So what are they?
Oh, minus 120, plus 120.
No, it's
Positive.
oh yeah, the angle. Yeah, sorry. The voltage is 122. That's why I got confused.
Okay. It's
Yeah.
about 92.
So yeah, the magnitude is 120 for each of them, and then the phase is minus 120 and plus 120.
Gotcha.
But that's not the part that makes it a little bit harder. So the one we just did, it was Y load, Y source. Those are nice because they're already set up to where you can do them as individual phases. We just did that the current was V over Z. We can't do that here because if you'll notice, it's not clear that the voltage is not the same. It's not the voltage across ZA, for instance, is not 120 angle 0.
Right.
So what we have to do is to convert it into a Y topology.
Okay. Right.
So how do we change delta to Y?
Divide by 3.
Divide the Z by 3, correct. And so when we change it to Y, we'll get something that looks like,
We're changing the Z load, right?
We're changing
Not
the load.
The impedance of the line.
no.
Right.
No.
You leave that separate.
Yep.
So by putting it into Y,
And these were originally 25 plus J5.
Okay.
So if we divide that by 3, we get 8.33 plus J 1.67.
Yep.
And then our voltages were 120, 0, 120 minus 120, and 120 plus 120. Okay, so now what do
Now
we
we
do?
can find the line currents.
Yep.
Okay.
And then, so now we can find the line currents the way we did on the last one, because now it's like we've got 3 single phases. Don't forget to include the transmission line impedance. So your total impedance, you'd add 3 ohms. And then, if our original problem was to find the line current right here, would we have to do any converting back? I mean, do we have to say, once we find this, do we have to convert back? Or do we have the right answer?
Oh, that's a good question. I think we have the right answer.
We'll have the right
because
answer.
we have voltage and
Right.
phase.
Right. So,
Okay.
all right, and did you get 1048?
So was that in phase form or rectangle?
Oh, that's in phasor form. 128 angle negative 8.37 for line 1.
Yeah, I think I put something. Oh, that's why I put the wrong one in. But yeah, that's right.
Okay, now, what if I had to put it in the time domain? I'd have to do one more thing, because these are going to be almost always given in RMS. And in the time domain, you would need to have it in peak. So like if we got our answer as 10.48 angle negative 8.37, the numbers from the problem were RMS, but when I put them into the time domain, I have to put it into peak, and so I would multiply the 10.48 by the square root of 2.
That's root 2. Okay.
And that would be 14.81. And then we weren't given a frequency, so we would just say omega. T, and then for the first line, it'd be minus 8.37 degrees. Amps.
That makes sense. Okay.
All right, okay, and that's going to be it for today.